I'm Mike, and I'm here for two reasons. One is I'm the UI architect of Yahoo Ads and Data, where we're building a lot of modern JavaScript apps. And I'm also the co-organizer of a meetup called Modern Web UI, where we're trying to foster cross-pollination between all the different framework communities and share ideas. In my spare time, I got something here. And back, sort of. It's better for us to have it at the beginning anyway. So I also try to contribute to open source almost completely in the areas of JavaScript and Ruby. Today I'm going to talk to you about the concept of taking a single code repository and from that code base building a web application, mobile applications that can be uploaded to the various app stores, and a desktop app that will be like an exe or a .app file that your users can, put in their dock or put on their desktop and launch independently of opening a browser. So in order to get there, so the second half of my talk is going to be a case study, and we're going to actually step by step build one of these apps. But first, I want to talk about sort of the state of HTML5 and hybrids. So there are many opinions on this, and I'm going to sort of walk through the timeline of how we got to where we are right now. Then I'm going to outline some of the cross-device technology that we're going to use to build the mobile app and to build the desktop app. Then we're going to dive into a framework, right? A framework that is robust enough to build something complex and one that's focused on productivity. And that's EmberJS. And then finally, we're going to build an app to look at GitHub. So how many people here know of GitHub or have used it? All right, at least a few of you guys. So this will let us look through orgs and drill into a repository and get information about that repo using the public GitHub API. So the iPhone came out, the first version of the iPhone came out in 2007. And the App Store came out in 2008, and people started thinking about how do I use this personal device and start, extending its capabilities. What are the business ideas that can come out of this? So shortly thereafter, you have frameworks like SentiTouch and jQuery Mobile, whose aim it was to create an app-like experience for users, despite it being written in JavaScript and HTML and CSS. These, by and large, were not nearly performant enough to deliver on this promise. There were like 1 or 2 second lags when you would open and drop down, and this had to do with a couple factors. So later, in 2012, people started adopting these apps and started trying it out and started working on performance. Then we have things like this happen. So Facebook in late 2012 decided to completely ditch their hybrid app approach, their HTML5 code base, and go for native apps. And when this happens, it turns the public's opinion away from this being a viable option, right? So Facebook knows what they're doing, they say it's bad, so I should probably not consider going in that direction. And that puts people in a position where they're thinking that hybrid apps are a poor choice, and then they're considering, do I build this native app? Do I hire a team that can write Swift, that knows the Android SDK, which is completely separate from what you need for a web application? Or do we just neglect mobile, or do we pick one platform and go for it? This decision is off the table. So right now, this is This is what we're looking at in terms of performance of the latest iPhone, the difference between today's latest iPhone and the latest iPhone at the time Facebook decided to part ways with hybrid apps. 7.5x faster for a generalized CPU benchmark. The browsers are better, the frameworks are better, the phone is better. So it's time to reconsider. This is a viable option for a lot of people. So on desktops, right, what about this device? Who knows which app this is? Spotify, great. This is an HTML5 app. And I doubt that most people who use it even know that that's what they're working with. This is a web application. There is a C++ core, but their desktop app is HTML, their mobile app is hybrid. They're really invested in this technology. And for needs like these, where you have URLs that start songs playing, a lot of the web app needs and the core principles carry through to build a great desktop app. So we've got things like chat clients, we've got things like code editors, which you can customize by using your own CSS. Lots of people are choosing to go this route. And this is not, there is no real performance consideration here. If you're thinking of desktop browsers as the standard for web performance, this is a desktop browser packaged with your app. It is largely the same environment. So the benefits of an approach like this, if you're already building a web app, you can leverage the skill and the experience of these developers that you're already working with. And they know how to build these things, and it's largely not a completely new paradigm. There are some new things that have to be considered, but it's not really apples and oranges. Functionality is not that limited. You can tap into the native functionality very easily in both cases, both in desktop and mobile. And as I said before with the Spotify example, the concept of URLs are still useful. You can deep link into an app so that it's, you click on a link online and it'll just open up a desktop app and you're in the right context. Layout and style are things that HTML and CSS do quite well, and HTTP and soon HTTP2 are the standard for communicating with third-party APIs. It's sort of the widely used way. So another thing to consider is that the shelf life of the web is longer than the shelf life of native. Web applications that were written 6-8 years ago work just fine. Native applications that were written like for an iPhone 4, if you get an iPhone 5 and the screen is longer and you get your black bars, as technology advances, these things aren't operating in the peak way that they were when they were originally built. So for the rest of this talk, I know there is a performance consideration here. I know that using native SDKs, if you're focused on 3D graphics, if you want to build an MMO, this is not the approach for you. But if you're largely building like a CRUD app where you're creating entries, or if you have a shopping cart or something like that, or you're browsing content, and then need to tap into some native-like functionality like get access to the sensors, connect to your user's address book on their phone, fire push notifications, this is definitely something that you should take a look at. All right, so we're done with step one. Now we're diving into cross-device technology. Two pieces here. There's Apache Cordova, which is the mobile piece, and then NWJS, which is the desktop piece. And these will effectively take a web application and they'll wrap it in something. And what you end up with in the end is it amounts to an executable, or something you can upload to an app store. So this is a little bit technical here, but basically what's happening here is you have a native piece and you have a web piece. They're communicating through some channel, and then the whole thing is communicating with your application API. So the red thing, the red box, your app, is what you're shipping. right? As opposed to just the web view, which is like your web application, that's what you're deploying. I mean, that's your code base, that's the majority of your work. It lives there. It's quite complicated when you look under the hood. But the good news is, the surface that most people have to touch is quite simple. And the point of this talk is to help you guys understand, if you have like a pet project and a little web application, or you want to try this out, there's not a high bar that you have to pass in order to get started with this kind of thing. It does get quite complicated as you want to integrate deeply and as you start pushing outside of the boundaries of what most people use this kind of thing for. So EmberJS, same idea. The difference here is that your web application, instead of communicating with some native mobile application piece, your web application will have direct access to Node.js. And this makes EmberJS a lot simpler. And the reason is, it doesn't have to create a bunch of adapters and a bunch of little plugins. Anything that's available in the Node ecosystem, Node libraries that make notifications pop up, or write to files, or convert things, or send out requests, or like a wrapper for the GitHub API, these are all things that you can use pretty much out of the box. So this is a much smaller piece of technology here. So if we look at these together, this is the abstraction. This is how I want you guys to think of what we're working with here. You have your app, and then you have the native piece, which you hardly have to touch, and that sort of gives you direct access to an operating system. I'm actually going to skip this next slide here. All right, so a facade. Who here knows what the facade design pattern does? Okay, not too many people. The idea is that you come up with a common interface, a common wrapper, and enclosed within that wrapper is some very specific code. But you only want to sort of put a simplified face on something that might contain complexity. In this case, if we want to send a notification, like a push notification, we can expose one method here that our app is using. You know, you've added an item to your shopping cart. We're going to use this. And if you're a desktop native app, we'll use Node growl, and we'll fire a growl notification, and it'll pop up on the right side. If we're using a mobile app, we will use Cordova's notification. And then sort of a fallback, we can have something within the app itself that kind of works everywhere. It's the least rich experience, but it works for anybody. So this is a pattern that will pay dividends. It really takes this split between the desktop app, the mobile app, and your web application, and you contain the details that have to do with specific scenarios in one easy-to-manage place, and the rest of the world sort of deals with a common interface. All right, so done with cross-device tech. That was a little deep. But the good news is we're going to lighten it up a little bit here. So Ember is a web framework, the focus of which is building ambitious apps and allowing developers to be productive. Ambitious apps, what does that mean? So Ember originated from Sprout Core, which was an Apple framework. It's a pretty old one, but it's what Apple used to build rich applications like iCloud and MobileMe. These are the kind of websites, when you visit them, you don't believe that your browser is doing this. It's very smooth transitions, a lot of animation, a lot of rich functionality. It doesn't seem like sort of a cookie cutter experience. That is what this framework is built for. It does handle simple apps well, but the focus is that large-scale apps and complex apps are a first-class citizen from the start. So it's used by a lot of people. So we use it a lot at Yahoo. Apple uses Ember in addition to Sprout Core. Square, if you've ever used Square for swiping your credit card, they use a lot of Ember. So it definitely has a large presence in enterprise and startup. It's pretty solidly backed. So why do people who love Ember, why do they like it? It's built around conventions. So if you've ever used Rails, you probably know convention over configuration. And the idea here is to take some of the small decisions you make, the potentially inconsequential ones, and to sort of take them out of the picture, right? To give you sort of a roadmap and a sort of a happy path. And if you follow that path, you have to write far less code, things sort of just connect. And if you have to sort of deviate, then there are hooks and customizations that you can make. But the more you stay along the happy path, the more you get to leverage the huge productivity increase you get. So one interesting part of Ember is that everyone who's on the core team, this group of developers who contribute hugely to the code base, they must use the framework in production. This isn't a group of like ivory tower software architects that build a framework and don't have to eat their own dog food. And not to imply that any other particular framework is in that situation, but I think they've done a good job in making this decision where they're not going to go down that road. Because any pain that the developers feel, they will also feel. They also work very closely with the TC39 working group, and this is the group that decides what is JavaScript, right? They define the standards. They adopt the drafts. And the what working group, it is basically the same thing, but for HTML. And it's worth noting that Angular and React are both adopting patterns from Ember, and there's a lot of cross-pollination that happens. Ember now, basically, it uses something very similar to React to render elements on the screen. Everyone's starting to borrow from each other, and it's interesting to see that these frameworks are starting to converge upon a set of widely accepted good ideas. One of my favorite things is Ember CLI. And the idea here is, this is the real productivity booster. This is what lets you get up and running quickly, prototype something quickly, and just provides a whole lot of utility with great ease. So it handles dependency management for you. It performs code generation. If you've ever used Rails, this is scaffolds. This is sort of like, I'm building a form and it has these fields and it gives you a starting point, something that works with a test that's passing. It includes an asset pipeline and a whole bunch of other things. And the add-on ecosystem, this is plugins. They can be installed with one line and sort of set themselves up. And because everything is built on strong conventions, sharing code within this community is extremely easy. So here, this is how hard it is to install Ember add-ons. Ember install Ember Lodash, and this is just a thin wrapper around Lodash, and it's up and running and directly accessible within any of your modules. So why does this matter for what we're talking about? Well, if we're setting out to build an app that it's a mobile app, it's a desktop app, and it's a web application, we need to be able to handle potentially complex situations. You may end up down the road forking, right? You may have something that only works on desktop, or on mobile, let's say, you upload a picture, but on mobile you want to take a picture with your camera and you have filters there. You want to set yourself up with a robust foundation upon which you can build something. You don't want to break out of the abstractions and find that you didn't have the right foundation, I guess. All right, so I'm done talking about Ember. Now we're going to use it. So here's what we're building. It's a GitHub browser. And the idea here is that you have a list of organizations. We're going to bring in the avatar for each organization. And then tapping on one of these tiles, and you can kind of see in the phone app in the background there, you can get a list of all of the code repositories that that organization has. So a good place to start is URLs. So on the left, we can see like, all right, if you just visit the app, you want to just end up with a list of the GitHub orgs for either of these two URLs. You want a URL for viewing an individual repository. You want a URL for the list of repositories. And then potentially you want a URL for details about one of those repositories. So in the Ember world, and in basically with any single page app framework, you end up with what are called routes. And these are sort of abstractions of a URL, and then what data has to be loaded for that page. And the router's job is to sort of connect everything up and attach the view and get everything going. So with Ember, all you have to do is type ember.js route index, and you can see that it's going to build the route for you. It's going to build the template, which is sort of your HTML file. Ember uses handlebars, and the idea here is to give you something that's declarative, but it's to give you something that allows you to put as much view logic in the HTML as possible, which sort of keeps everything else clean. And you'll see what I mean in a moment. Oh, and then it generates a passing unit test, which is interesting, right? This is a good starting point. In this case, it's just going to make sure that when you visit the URL, it's actually there. And this would prevent you from accidentally deleting a file, and this test would fail. So we just need two models here, one for an org and one for a repo. And these are the corresponding GitHub API endpoints. So I'm going to jump over here and show you what this looks like so far. Great. So this is the app. This is like creating a new app. You will end up with this as the starting point, and we won't worry about that. Okay. So Ember CLI is running right now, and what it's doing is it's running a development web server. Any change I make to the code will be very quickly. Run my cursor here. It'll be very quickly updated. So if I change this to and save it, you should see it refresh immediately. So this really, if you're adding content or you're changing styles, this is very nice. You immediately see the effect of what your changes are doing. So I'm actually going to skip ahead here in the interest of time. All right. So this is sort of a save point where I already created these routes that I told you about. And the important thing is I can visit URLs now. And Alright, great. So I can go to orgs, or I can go to org, jQuery, repos, and we start seeing things, right? And the reason we're seeing things is I've just added some text to these little HTML files. So you can think of this as sort of nested pieces. You've got your application, you've got the page for an org, which is, this is the title of it here, and then inside that you've got the list of repos. It's a hierarchy. So let's add those models and some code that will talk to the API. And what we end up with is a list of repos that this jQuery organization owns. And all you have to do for this, just to show you the template, we're just iterating over this list. It's It's a UL, and we're putting a list item with a link in it for each repository. And likewise, if we go back to orgs, right, so we can drill into jQuery, we can go back. This is like the minimum, this is the data coming in, the data that we need, right? All right, picking back up here. Right, and just like with creating a route or installing a plugin, pretty much everything is a one-line command that sets you up with a good starting point, so at least you can see that everything works. Talking to an API, you have something that will figure out which API endpoint to hit, and a place where you can customize the payload that comes back, so that the adapter in serializer is where you would do that. All right, so now we need to make it pretty, because that app that we have right now won't do. So we're just going to install some material design styles, and you just do that again with one line. And this is more powerful than using something like NPM or Bower. It's actually built on top of the two, but these libraries will have an opportunity to say, like, after I am installed, run this code, and that will let the library, potentially modify a file that it needs to modify. And you have the opportunity to look over everything before you commit it, but sometimes you need a configuration object, or sometimes you need something to get things set up. And this is an effort to make things as easy as possible to follow this conventional happy path. So going back. I'm just going to switch to step 3 because I don't want to get trolled by NPM. And so all I did was switch to a new branch. Again, this live reload technology picks up on the fact that some code has been changed, and now we have some interesting styles here, right? This is starting to look more like an app that could work across device. So a key thing to note is we're using some responsive breakpoints, so that on an iPad, you see that we've got a nav bar on the top, or for wide screens, like desktop mode, you have a link in the toolbar, and then as you collapse down, you get your Burger King menu on the side, and when you click it, you can go to the equivalent link. So this is nice and responsive. And further collapsing, you can see that it'll go down to mobile. Go down to like a phone size and be nicely scrollable. Right? And clicking on one of these should take me in here. So this is really, I'm skipping little 5 or 10 minute pieces of work here. The key power you get here that you may not get with less opinionated and convention-oriented approaches is that these libraries install themselves. They're building blocks that are ready to go, right? All right, so we can go back to the slides here. All right, so now we have to hybridify it, right? We need to create the Cordova app. So we're going to have the hybrid web app. We're going to have Cordova, which will build an Xcode project for us that we can open, right? We could add Swift to it or add Objective-C to it. But with Ember, it's 3 commands. So I've already got it installed. So I can just do Ember, Cordova, build. And what it's doing now is it's reading, oops, I guess I don't know what's all. So it's setting up this Xcode project. It's going to add some little hooks so that this live reload will continue to work. We're going to be able to make a code change and watch the app, potentially like on a test iPhone device. We're going to use the iOS simulator, but we're going to watch it refresh. This is a development sort of workflow that native app developers don't really get to enjoy. Sort of change something, 5 seconds later, see what it did. Change something and see what it did. All right, and now we're going to do Ember serve. And what Ember serve is doing, that's fine. It's already running, that's what it's telling me. So this is just a little shortcut to open up the Xcode project. It's starting up here. Screen. And here we go. So this is equivalent to running on an iPhone, right? If you provisioned the development device and installed stuff, like installed this app on it instead of making the target a simulator, you would be seeing this running on your phone as a completely native app. And if we look, there is, you know, potentially, here's your www folder, this is your web app, right? And then you've got other stuff in here that is, it pertains to sort of Cordova's bootstrapping code. Great, so now we actually have our mobile app. If we go back to the home screen, so you can see, I mean, you can customize your icon here, but it is an app, right? All right, awesome. We got the mobile app piece. All right, now we want to make the desktop equivalent. Let me see if I can get rid of this. So, oops, I have the wrong command in here. This is using this technology called NWJS. Basically, a similar thing, a similar concept. I believe I still have it installed here. So I'm just writing Ember NW. All I did was I installed this. It took a little while to download because it had some packages that are specific to OS X. We're just getting deprecation warnings here. All right. So we have a native app here. Here it is in my desktop, in my dock, sorry. And kind of still looks like a browser though. And if the screen wasn't clipped here, there's a menu. Well, you can add stuff to the desktop menu. This is like going beyond the web app, right? You do like file save, file open, or an about page or something like that. Unfortunately, this still really looks like a browser. I mean, this is like, this is Chrome's DevTools here. This is showing a little bit too much browser. It's very simple. You simply have to add some stuff to your package.json to describe some constraints about the window, right? So here we're going to give it a new title. We're going to take the toolbar away. We're going to only allow it to get to 601 pixels. Here's why. This is down to phone mode. I think this is kind of strange for a desktop app. This is not an experience I want to have to maintain here. It's kind of wacky. I would rather have only this 2-column layout. And the point at which that switches over is 600 pixels. So I'm effectively locking users out of the phone-like experience when they're like running in the desktop app. So we can just make those quick modifications. Replace the default window object, leave a straight semicolon. So kill the existing app, restarting it, and hopefully it just works. Awesome. So now, this is looking way more like a desktop app. I mean, you have sort of the web app look and feel, right? Like, this is something you frequently see in web apps. But that's just a matter of style here. You can see that I'm no longer able to make this, like bring it into phone mode. So great. All So we're getting close to the end of the talk here, and I just want to kind of recap what we went over. We talked about two technologies, Cordova and NWJS. They wrap your web application and expose native functionality. And that means you can tap into notifications, you can tap into, on mobile devices, the camera, get access to contacts. You know, if you've ever seen, like, clicking on a link will open up a browser within the app, and you can close it, you're not, like, switching over and going to Safari. That kind of functionality is there. And I think it's overlooked. And in light of the fact that a phone you buy today is 7.5 times faster than a phone that you would buy 3 years ago, some of the performance judgments that were passed on it should be looked at again. So if any of you have any more questions about this, or if you want to just chat about web technology, or the potential nuances between mobile, desktop, and web, and like how we can sort of make this one repository, deploy everywhere experience as feasible as possible, reach out to me on Twitter, and I'm happy to take any questions that any of you have. Yes?
Is the desktop app installable by end users?
Good question. There is no need to install it. And the reason is the core technology is Chrome. Effectively what the desktop app is, it's Chrome, strip away all of the UI for it, and then also package with it your app, and that Chrome can only go to your app. So as it stands, Chrome can just be downloaded and run without any installation process. It doesn't need to modify any registry or set up anything. So really it's just, you could have this on a flash drive and just run it. It's very standalone, if that makes sense. And that is something that makes it very appealing if you deal with corporate customers. So how many of you have written apps and then found that you're dealing with like people that have fleet laptops and they don't upgrade except once every 3 or 4 years? Wouldn't it be nice to ship the browser that you're using the app with your app? Then everyone's using Chrome. You could use Chrome-specific features. Everyone's on the same platform. And we as web developers don't often get to make that assumption. So I think there are some interesting opportunities there. Yes?
So since it runs in Chrome, if you do have some corporate laptops that say use registry settings to restrict it, would it still abide by those registry settings?
Like you have some registry settings that are locking out Chrome?
Locking, you can
Gosh,
lock out certain things.
that's unfortunate.
I know I created a whole bunch of PowerShell scripts to get rid of those.
Don't tell me where you work. I would think that because this is running as Chrome, I would think that if that method of preventing things is any good at all, it would probably prevent this. Otherwise, people could just rename a process, or it'd be very easy to defeat if this were able to defeat it. Anything else? All right, thank you all very much.